Okay, students, let us now solve some examples on motion in 2 dimensions. We have an eagle is 19.5 above the water, and he starts his motion in velocity v naught is equal to 3.1 meters per second in direction of the angle 20 degrees below the horizontal. So this angle is also 20 degrees. As we see, we have here right triangle. We know the relations, trigonometry relations for the right angle. Okay, what is the requirement from this example? First, we need to know how much the time need the eagle to reach the water. Also, we need to know how long he will travel to reach the water. We need to know r, the third side, not x, not y. Y here, his altitude is 19.5. Okay, for the right triangle, we have sine theta, this is theta, which is 20, is equal to y, which is h, over r. Okay, we need to compute r, this value. Also, we need to compute the time from the starting point to the end point. We can compute the time after computing r. After the second step, we will go back to the first one. Okay, how can we compute r? We can do that in many ways. We can use the first relation here. From the first relation, r is equal to y over sine theta. Theta in degrees. I can now put y, it is the same as h, which is 19.5 over sine 20 degrees. This will be equal to 57.1014 meters. We can approximate this to 57 meters. This is the distance which the eagle will travel. Okay, how much the time? We know the velocity, and we know that velocity is equal to displacement or distance. We have here a vector quantity, which is the velocity, so it will be equal to change in in position, which is displacement, as a vector, divided by delta t. Now I need to compute delta t. Delta t is equal to the displacement, which is r, and the direction of this r is 20 degrees below the horizontal. Okay, here I need to put r as a numerical value divided by the numerical value and the magnitude of the velocity. The velocity is 3.1. R is equal to 57 over 3.1, which is equal to 18.39 seconds. I can approximate it to 18.4 seconds. This is the time elapsed for the eagle to reach the surface of water. Also, we can find the horizontal displacement. We can find the velocity, the components of this velocity in x direction and y direction in this way. We have, this is the velocity, which is 3.1, and this angle is 20 degrees, the velocity in this direction. So I have it, this is Vy and this is Vx. Okay, how can I find these components? I need to draw the xy plane. This is x and this is y, and this is the velocity. It is 20 degrees below the horizontal x-axis. Okay, this is the velocity, which is equal to its magnitude, 3.1 meters per second. So I have its component to the x-axis to the positive direction. This is Vx, and negative component for it for y, Vy and y negative axis. Okay, I can now compute Vx, which is equal to V as magnitude cosine, which is, because the angle next to the x-axis I use cosine for it, which is cosine 20. In this case, V is equal to 3.1 multiplied by cosine 20, which is equal to 2.9, approximately 13 meters per second in x direction. Also, Vy is equal to the magnitude of V. I don't need to put this in the solution, but I put it here to know that this velocity in x direction, this is Vx, and Vy is equal to V sine 20, which is equal to 3.1 sine 20, which is equal to 1.06 meters per second. I find now the y component for the velocity and x component. The x component in positive direction for x, and the y component in negative direction. So I know that physically, in physics, y in negative y axis. So I can put minus sign, or I can put it here in minus y direction. Okay, now I have a long